Um, this little video will be uh, focusing on the results and discussion part where you would actually put your data into your formal lab report for my class, and showing a sample calculation in Microsoft Word. Uh, so in your section heading, results and discussion, or sometimes it's called data, or data discussion or whatever. But this will be where you put your information. So I copied and pasted basically my table from that I created in Excel. I made it a little bit more detailed though for my formal report. In the APA format, you would have table one, and then you would have a title or whatever for that, a descriptor for that table, and the other table just said copper wire J or whatever. This is measured and calculated data for copper wire J, and that's the data from the Excel spreadsheet. And then in APA format, you would have um, a description of the table. Underneath that, I'm highlighting it there. You don't highlight it in your paper, but um, you would have that, you know, in your underneath your table, um, and the details about how to format that you can find it if you don't have your own sixth edition APA manual or whatever. You can just simply use the Purdue online writing lab, or the OWL, Purdue OWL, and look at APA format for tables and figures. Um, and so some of that would be beneficial. So here I put table 1 displays calculated diameters limited to 3 significant digits due to the density value for copper used in the calculations. That limited my reportability, because even though I had 4 significant figures from my analytical balance and 4 from my metric ruler, my density, when I calculated diameter, since I used that density, it was limited to 3 significant figures. And then it tells a little bit more about it. Samples of wire J were pure solid copper wires with no insulation or coating present, aka bare copper wire. So, just to show that, we didn't mass out insulated copper wires and then go, calculate a diameter based on that added mass. It was just the copper itself. Therefore, we use just the density of copper. Um, there's the equation um, that we use the equation editor for in the Excel video to create that. Here's some more information, the same stuff from your Excel document. At 20 degrees Celsius, 8.92 grams per cubic centimeter will be the density of copper. Of course, that's from my textbook. The value for pi, up to that many, decimal places. This value of my average was closest to that, which was a wire size AWG 26 from the Ted Pella Incorporated website. And that's still on there. I would probably, on my actual document, I would take, if you included that, it's fine, but I don't want you to have it, um, like underlined or whatever. It's if it's in the box. Um, okay, so this is a section heading here, results and discussion. This heading, sample calculations, is still part of that. So I don't want to center that. And also notice how there's just a couple of lines of it on the page with this information. You never ever cut a page in the middle of a table. You don't do that. So You want to format everything where it fits nicely. But let's just say this information starts to carry over. Let's just say I want to start a whole new page right here after this when I start my sample calculations. So click just to the left of that and go to Insert Page Break, and it will put it down to the other page. Now, of course, this would all be a heading up here for your lab and page numbers and all that. But some of the givens that are there where I got them, the density from the book, another book that I have. Let's see, this is an engineering handbook. The original formulas, and I just used the equation tools, equation editor, to enter all that stuff just like I did. It works very similar to what it did in Excel. I just added another couple little things there. The diameter in millimeters is 2 times this, and then at the end times 10. So to get it into millimeters, because grams over cubic centimeters, and grams up top, that's going to give you centimeters, and then you multiply by 10 to get millimeters. So the average diameter of the wire was this, and the actual was that gauge that goes with it, because there's its actual diameter. So what do I want you to do for a sample calculation after this? Well, just simply, I'm going to put wire J sample 1. I'm going to take this whole equation right here, and I'm just going to copy it and paste it. Okay? And then all I'm going to do is replace these things inside here. So I'm going to, at the end of that, I'm going to enter one more time, and then maybe one more time like that. So in this middle one right here, I'm going to put the numbers for that, for sample 1, for my data table. The mass was 0.1833, like this. So 0.1833, and then grams. The density was 8.92, and then all I do is get rid of my parentheses I don't really need. Oops. Actually, I want to put that 8.92 and where the right beside the grams. 8.92 space grams per cubic centimeter times pi. Just leave that alone. And then the length in centimeters, I'm going to put 15.98 centimeters. Just like that. Times 10, right? And then whatever that comes out to be, well, that's already in your data table. So 0.405 millimeters. And it's up to you if you want to put that, 0.405 millimeters. Like that. And that's that sample calculation. And then percent error, that also was your average, if you remember correctly, right? Your percent error calculation equals, actually, I want you to go to the insert equation part, and we'll type it in there. Alright, so percent error equals, and remember that it's first a fraction that you put in there. So And then inside the top box, you would put brackets for absolute value, which are just two vertical lines. And it's the absolute value of the error, which is the actual value. So in this case, it's actual diameter minus experimental diameter. Absolute value, so if it comes out negative, the negative sign goes away. That's your error or your difference, the absolute value of the difference there. And you just divide this by the actual value. Or the accepted value. And whatever that comes out to be, you multiply by 100. So your difference is, if you just take that where you can select the whole thing and copy, Control C, and then move it over to the left, and then Control V to paste it. Now you can type in the numbers. So you can put in the diameter from here, 0.40386 millimeters, and the experimental average was, I misspelled diameter, no, I didn't catch that. The experimental average was 0.405 millimeters, and then you're going to divide that by the actual or the accepted, depending on the terminology that you're using, like that. And then I just copy and paste that one more time, like this. So when you subtract those, you're going to be limited to the third decimal place. And I forgot my millimeters. Very important to keep up with your units. But this is a negative value, but on the top. So because you're subtracting 0.40386 minus 0.405, and that gives you like negative 0.001, right? But it's absolute value. So you're going to, I'm going to take this, I'm going to just put millimeters after that because it was still millimeters. But you know, it's not going to be negative. So I'll just take that and, you know, put 0.001 times 100, and then you're going to have to round that also, your answer. And so I want you to put insert, or you can just click inside of that, and then look at your design tab and give me the squiggly equals, right? One significant figure, which is 0.2% error. And then you should have from that enough to show the sample calculations. And I want you to, you know, just practice that using the equation editor. Just make sure you check units and stuff like that. And I hope I didn't leave anything out, but I'm always available if you have questions, okay?